So in this course, we will be learning one of the cloud, that is AWS or Amazon Web Services. In this cloud, we will be learning various services which the cloud has been providing. So initially, we will be trying to understand what is cloud and segments, different segments like SaaS, PaaS, and IaaS. What are these abbreviations? I will explain in a moment. And what are the different models available in the cloud? And what are the essential characteristics of cloud? And the course will start from basic, actually from basic. Even you are non-IT or IT, we will start from from basic. So initially we will start what is server, what are networks, with very basic. We start from scratch, and then slowly we will move to the cloud. So after that, we will be creating the account in the cloud, and then we will try to understand various terminology on the cloud. One of the main terminology are regions and availability zones. These are important terminology. Once you understand this, then you get some confidence what you are doing on the cloud. Then what we do is, on the cloud we will be going to exactly whatever we do in real time on the on premises. Every company, like you take any company, like big companies, large companies, they are having their own data centers. Data centers means, you can in a layman terminology, I can say it's a big building. It's a big building. In the building, there will be hundreds of machines or servers running, right? So the same thing, we call that setup as, we call as data centers. The same thing we will be going to create. So we will be creating servers on the data center, but this time not on the particular company's data center, but this time we will be creating servers on the cloud provider's data center. So we'll be learning how to create servers or machines. So not physical machines, actually we are going to create virtual machines. What are virtual machines? What are physical machines? What is the difference? All those stuff we will be learning step by step. But in this course, just I'm describing the high level description only I'm giving here. So if you are not understanding anything, then don't worry. Whenever we start, I will be explaining them with from scratch. So here is the EC2, or we call it as Elastic Cloud Compute. This is nothing but a virtual machine. We'll be learning how to create virtual machine on the cloud. Then we'll be learning more about security groups and creating various different security groups. Why security groups require? So how it helps us to connect to the system. Those things we will be learning. Okay, and then no, we will also learning what are ports. Why we require ports? So basics again. So here I've just said enable different ports, I'm saying, but no, before this statement, I will be explaining what is port, why port required. Those things we'll be discussing from scratch. So here again, different IP addresses available, like public IP, private IP, elastic IP. Why we have those many IP addresses? First of all, what is IP address? What is internet protocol? Those things again we study from scratch. Then we have storage services. Like anyway, we are creating the servers on the cloud. Then definitely you need to store data on the right. You have to store the data. So how the cloud provider, that is AWS, how this cloud provider allowing us to store the data? So what are the different types of storages available on the cloud? Those we will be studying under storage services. So like we have S3, simple storage service. This is one of the storage. It is similar like your Google Drive. It is similar like your Google Drive, even more than that. And then we have EBS, elastic block storage. What is elastic block storage? It is nothing but like your hard disk. Same like your hard disk, we have a service called EBS, elastic block store. And we have elastic file system. Like you have shared folders, right? In real time you have shared folders. If you don't know what shared folders are, then we will anyway at that time I will be discussing from basic, and then we will be entering into the topic called elastic file system. So any topic you take here, I will be giving background, and I will be comparing with the things which you already know, and then we start from there. Similarly, we have Glacier Storage Service. So Glacier Storage Service means the storage where you can store data for a long time with a cheaper cost. So again, storages applies different costs apply. So we have to store data in cheaper storage. Why we have to store in the cheaper storage? And then we will be learning about IAM. So IAM is nothing but identity access management. So in real time, when you are working in a company, so you will be logging as a IAM user. I will be logging as a IAM user. So root user also will be login. So sign in using root user, sign in as a IAM user. What is the difference between IAM user and root user? Those things we'll be discussing. So before we learning these topics, so IAM, identity and access management, we'll be covering. And then AMIs. AMS in full form is Amazon Mission Images. So we have default images and custom images. What are these? So this again here it takes long time. We have to spend a long time here to understand these images things. I will be explaining that, but not immediately now, so that our course, our schedule, our session will be, agenda will be what do you call, so it will take a different route. That is the reason I'm not getting into depth of these topics. And then introduction to CloudWatch and configuring CloudWatch. What is CloudWatch? So CloudWatch is a service. Please be on mute if you are not speaking. Yeah, thank you. So introduction to CloudWatch. This is the service which actually watches the health of the servers. Suppose assume you have created virtual machines using our a service called EC2. So when you created a virtual machine on the cloud, then the virtual machine maybe in the application deployed in the virtual machine may be consuming more CPU or more RAM, or the application may be behaving abnormally. In that case, the server may crash. So before it crashes, suppose I want to get alerts, because I'm a cloud engineer, I want to get alerts. So basing on that, I can take some actions. So how you can get alerts? That you get it from using a service called CloudWatch. CloudWatch always monitors your virtual machines. How we can use CloudWatch to watch the virtual machines, we'll see. And then concept of CloudTrail and configuring the CloudTrail. What is CloudTrail? So as CloudWatch is watching the activities which are happening with the application may be using the RAM CPU. It is watching how the application behaving. Those things your CloudWatch will watch. I mean to say, it will watch the infrastructure, how the infrastructure has been used. But whereas CloudTrail, it is opposite of that. The CloudTrail will watch the activities of the user, what the user is doing. For example, suppose tomorrow you logged in but accidentally you stopped a service, some of the service you stopped, or you terminated some of the service, so which accidentally you did it, then you again restored it back, for example. But this activity whatever you did, no, for everybody's activity, your CloudTrail will automatically log that information. It will log that information. And so that, no, if tomorrow, if any audit goes on, in that case, who did what easily can be detected. So that is the reason we use a service called CloudTrail. And then we have very important topic, that is virtual private cloud, VPC. We call it as a VPC. So what it is? It is same like your data center. So as I told you just now, every company will have a separate building. Not every company. So most of the old companies nowadays, many companies are startup companies. The startup companies, they don't have their own data centers. So again, right, if you want to have your own data center, then it is very expensive. So it is very expensive. That is the reason most of the startup companies, they don't have any data centers, but instead they use the services of the cloud providers. They use the service of cloud providers. So VPC is nothing but it is same like you can think it as a virtual data center. It's like a virtual data center on the cloud. So who is maintaining this virtual data center for you? The cloud providers. So today we are seeing about AWS cloud provider, but we also have Azure, we also have Alibaba, we also have a Google cloud provider. So many cloud providers are there. So they have their own data centers. So we will be using part of the data center. So that part of the data center which we are using, right, that we call as virtual private cloud. So in this virtual private cloud, we will be understanding how we can create a custom VPC. What is custom VPC? When I'm saying custom VPC, there should be a default VPC. What is default VPC then? So these things we will be try to distinguish, and we will learn, and why we have to create our own custom VPC, how to create them, that also we will be learning. And what are NACLs, what are security group, how to create internet gateway, why we require internet gateway first of all, and how to create subnets, why we require subnets, what are public subnets, what are private subnets. So these things, anyway, I will be explaining in our beginning session only, where the session starts on introduction to servers and networks. At that time only, I will be giving you some introduction about subnets, so that, no, by the time you reach over here, I will anyway recap those details again, so that you will be comfortable learning the subnets. And then we will be, because subnets are required, because in that subnets only we have to create the virtual machines. So why we have to create the virtual machines in subnets, and why we have two types of subnets, those things we will be discussing in depth at the time. So creating instances inside the subnets, and creating route tables. What are route tables? That also we understand. Creating NAT instances, NAT gateways, creating VPC peering, creating VPC endpoint. All these things will be learning at the time of learning virtual VPC. This is very important concept. And then we will be learning creating auto scaling group and assign instances to auto scaling group. Auto scaling means, see, in real time, whenever you are creating instances, for example, suppose you want to create 50 instances, 50 virtual machines, right? At that time, assume due to some reason two machines or two instances are crashed, two instances is crashed, then we left over with only 48 instances. So in that case, your auto scaling tool, auto scaling is a service which is job is maintaining the number of instances which you want to have always. So we will already inform to auto scaling that always I should have 50 instances running, but somehow two instances are terminated for some reason, then only 48 are there. Then your auto scaling will immediately detect this, and it will immediately add two more, it will add two more. So so always your auto scaling will take care of creating 50 machines. That means initially we will be learning how to create instances ourselves. How can we create the instances? We will learn, and then that job we will be delegate to auto scaling service. In real time, we always use auto scaling only. So we will not do manually. If you do it if you create manually, then if anything goes wrong, any instance is crashed, then again using CloudWatch will alert you, and you have to recreate the instance. To avoid such things, you can go with auto scaling service. Similarly, we have load balancers. So what is load balancers? See, as you know, every day maybe you maybe used various e-commerce websites. One of them is Amazon. So Amazon daily, I'm saying that daily, for example, 1 lakh people are connecting, 1 lakh people are connecting to this website. So when 1 lakh people are connected to this website, then how many servers we should have? So we should have easily some 20,000 servers we should minimum. I'm just guessing, I'm not saying exactly, approximately assume 20,000 servers are running, and these 20,000 servers are servers serving, okay, serving 1 lakh people daily, 1 lakh people daily daily, for example, just a example sake I'm saying. So then this 20, suppose 1 lakh people are connecting these servers, and the request should go, suppose the one of the person want to buy a laptop, he want to buy a laptop, then the request should go to the Amazon application. The Amazon application is running on all the 20,000 machines. This I will explain very detailedly at the time, but here I'm trying to explain this very quickly. So 20,000 on 20,000 machines our application is running, and one of the person want to buy a laptop. That request may be delegated to sent to one of the machine. Out of 20,000 machines, it will be sent to one of the machine it will be sent. So which machine it has to send? Assume that the request sent to a machine number 301. So 303 is a machine, is a server. The request sent to this machine, but this machine already processing another customer's request. It is processing another person's request, it is already busy. But if the request again, one more request coming from another customer who want to buy a laptop, if you send the same request to the same server, okay, then no, the server may first it has to finish the previous request, and then it has to serve the process the next request. So in the meanwhile, the customer has to wait. The customer has to wait. So that is the another problem. That is the reason we will have a load balancer. We will have a service called load balancer. What the load balancer job is, whenever any request coming from the customers, the request first goes to the load balancer, and the load balancer will check which server is free. Out of 20 servers, which server is free? So when whichever server is free, to that server that request will be forwarded by the load balancer. Okay, so these things we'll be learning at the time of load balancing. Similarly, we have AWS backups and backup strategies. So normally in real time, administrators on the physical or on the on-premises or other physical data center, they do daily, they take backups daily, weekly, monthly backups, or they can take on-demand backups also. They take on-demand backups and on-demand backups. They call as on-demand backups. So these are the backups they take regular basis. So we will try to the same backups we can also take on the cloud. How we can take those services, how can we achieve this thing on the cloud? We will be learning this as well. And then Lambda. So Lambda is another service. Normally when the developers develop the code, the whole code has to be deployed on the server. So for example, in this case I'm talking about 20,000 servers. In the 20,000 servers, Amazon application is running. It's Amazon application, it's a web application. It is running on 20,000 servers. So, uh, you have to pay. You have to pay. Uh, Actually, first of all, we have not learned what is cloud computing, right? But anyway, I will explain that in a second, in a few minutes. So, these 20,000 servers, since you are using, for that you have to pay to the Amazon cloud provider, AWS cloud provider. You have to pay the monthly way, monthly. You have to pay the bill for using these 20 servers. Assume you are using Amazon's EC2 instances, for example. Okay, EC2 instances we are using. So for this 20,000, you have to pay. Because why you have to pay? Because you have deployed your application on all the 20,000 machines. Your application running on all the 20,000 machines, right? So then what you have to pay? You have to pay for the EC2 server. You have to pay for the CPU. You have to pay for the RAM. You have to pay for the hard disk. Everything you have to pay for. You have to pay for the networking. Everything you have to pay. So it's a huge. Every month it will be generated huge bill. But if you use Lambda, then what happens is that the Lambda is called as a serverless. It's called as a serverless serverless service. So what is serverless service? So what it is? That means in the name saying serverless. That means there will be no server. Meaning is there will be no server. Still you can deploy your application. Still you can deploy your application without creating any server. Okay. So all we need to do is you have to deploy your code on the cloud. So you have to deploy your code on the cloud using Lambda is a service. When you deploy your code using Lambda, we call it as Lambda functions also. I will be explaining more detail at that time. But when you deploy your code on the cloud itself, at that time your cloud provider says that do not create any server. You leave that to us. You leave that to us. So just upload your code, okay, and convert them in the form of Lambda functions. Then so normally maybe if your developers are, or some of the maybe developers or somebody may not be developers, but understand that whenever any project is developed, using any programming language, project developed any of the programming language, okay, then this any language you take, you may be knowing many languages, maybe Java, right, C, right, C++, many are there, right, many languages are there. So every language, they have a concept called functions or methods. What are these functions, methods? What are these? Actually what happens is, so whenever they do the programming, the program they write the logic actually, the instructions they write, the instructions can be easily, it can occupy more than it can be easily 50,000 lines of code. It can be 50,000 lines of code. So they cannot write all these lines serially. They cannot write. They have to divide into functions, small parts, small, I can say small code chunks, small code snippets, I can say. Okay, they have to convert them into functions. So these functions we have to bring, we have to whatever you written in these functions, those functions code you have to move into Lambda. So Lambda is same like a function that you have to, every function, suppose you have divided the 50 lines of code into functions. How many functions you have? For example, assume I have 500 functions. I have 500 functions. That means you have to create 500 Lambda functions. So what happens is that whenever you whenever this function is executed, so every function will have some 50 lines. 1 minute, 50 lines, 550 lines of code, for example. 1 minute, please. 50 lines of code in each function. So when you move this 50 lines of code when you move this function code into a Lambda, so assume that 50 lines are executed. 50 lines are executed are executed. For executing this 50 lines of instruction, it took, for example, 3 microseconds. 3 microseconds. Then for the 3 microseconds, you have to pay the bill. You have to pay a bill for executing this code, which took 3 seconds. Like that, every day, thousands of lines will be executed into, you can how many seconds you executed, the total, the instructions execution time period, for that you have to pay. But you no need to pay for the servers. You need to pay for the 20,000 servers. You need to pay for the RAM used, for you know to pay for the CPU used, not need to pay for the hard disk. So only you have to pay for the execution period which it took to execute the instructions. Anyway, I will be explaining more detail about Lambda later on. And then we have, so this way if you use Lambda, lot of money will be saved. And then we have Amazon simple notification service. So this is the name itself saving, it is a notification service. Notification means, for example, as I told you, CloudWatch example. So CloudWatch, whenever the CloudWatch watches the infrastructure, and whenever it finds that one of the application is using CPU or RAM more than 80%, then your CloudWatch immediately will inform you through a mail. But how you receiving the mail? You receiving the mail because with the help of SNS service. That means CloudWatch internally it uses the service of SNS. So SNS is a service which will be used by different services like CloudWatch, like autoscaling. Even your autoscaling also will inform us whenever an instance is created, whenever an instance is crashed. Those details will be send us through mails with the help of SNS. That means your auto scaling service or your CloudWatch, they will not have capability to send you emails, but the SNS service have the capability to send the emails. So we'll be learning a simple quiz service. What that is, we will be understanding at that time. We're learning the quiz at the time. So mostly this is used by microservices or so you who are not talking, please be on mute. Some noise is coming. And then we'll be learning Elastic Beanstalk, we'll be learning Relation Database Service, we'll be learning Cloud Development Kit and Cloud Formation. These things, even I explain now, we may not get it as of now. So these are the various services we are going to be created, learning. That is cloud computing. What is cloud computing? So as I told you, before the cloud, you not normally what used to happen is that if you needed a server, you had to buy server, you have to install the software, you have to maintain the server, you have to replace if anything goes wrong, like RAM, CPU is not working, you have to replace them. For doing this thing, you have to need have a IT team, and then you have to create the networking, databases, your user management, many things you have to do manually. All these things you have to do manually. So mostly, no, for example, any company got a project. Suppose a company got a project, and the project requires assume 50 machines. Then before cloud, the company used to buy 50 new machines, or they may use the existing servers. If already they have 50 servers, they can use them. If they don't have servers, then they have to buy new machines for that project. Once the project is completed, then those 50 machines may be reusable or may not be, because the projects normally take to complete around 2 to 3 years. After completing 2 to 3 years, the hardware may be obsolete. That means those servers may not be reusable, because after 3 years or 2 years, no, latest new softwares will come, and those are not feasible to deploy in these are old servers. So the 50 servers may not be usable. So there will be a lot of wastage happening in those days actually. But when cloud came, those things are buying the servers are now slowly decreasing. So cloud computing is a computing paradigm shift where computing is moved away from personal computers moved out from personal computers or an individual application server to cloud of computers. Users of the cloud only need to concern with the computing service being asked for as the underlying details of how it is achieved or hidden. That means now using cloud computing, so like AWS. Now you can ask AWS cloud provider to provide 10 servers or 20 servers for your project. They will provide you. You can use them. So once you use them, then you have to pay for that. Because you have used them, you have to pay as a rent. You don't need to buy, but you are consuming their resources on a rental basis. So this method of distributed computing is done through pooling all computer resources together and being managed by software rather than human. So what happens is that these cloud providers, not only AWS, you take any cloud provider, they will have their own buildings. They will have their own huge buildings, and in that buildings they call as them as data centers. In that they have the physical machines. In that they will have the physical machines. From that physical machines, they create the virtual machines. If you don't know what are virtual machines, please leave that for now. I will be explaining that thoroughly in the coming sessions. But now try to understand, whenever you want machines, then you can request the cloud provider, and the cloud provider will provide you the required number of servers to you, and you can connect to those servers remotely. You can connect by sitting at your home. You can connect those servers remotely at your from your office. You can connect them remotely, okay? But they will provide you. This method of distributing computing is done through pooling all computer resources together. So they will buy, the companies, cloud providers will buy the servers in huge quantity, and they will give that servers to on rental basis to other people. So like companies also, like Infosys, TCS, you name it, all companies, they can rent these servers. They no need to buy. They can rent these cloud provider servers, and they can use them for 2 hours, 2 years, or 3 years, or 6 months, or one day, 2 day, any time period they can use it, and they can pay the bill whatever period they have used it. And then possibilities, what are the possibilities? Because of this reason, it is possible to consolidate all the needs of organization in a systematic and accountable fashion. So this way, they can, the startup companies, for example, startup companies no need to buy physical machines. They can simply connect to the they can take avail the services of the cloud provider. The companies, the startup companies can recruit developers and other people, and they can purchase laptops with which are not what you call thin. We can call them thin client. That means they are not very efficient as laptops, very cheap laptops. And using those laptops, the developers can connect to the cloud. On the cloud, they can create powerful servers, and on that start they can do the development. Okay, this way the startup companies can invest less amount for the laptops which are very cheap one, that cheap in the sense which require only browsing capability. If the browser runs on that laptop, that's enough. We require only browser to connect the cloud. That's all. Even you take a basic laptop also fine. So that way you can connect to the using the internet. You have to connect to the cloud, and from there on the cloud you can request whatever servers, what type of servers you want, you can request there. How many you want, those many it will be created for you. If you want 100 machines, you can get 100 machines. It is possible to procure computing related resources similar to how you rent a place for living. So same like how you rent a house, for example. Same way you can rent any resource on the cloud. For example, you can rent a storage on demand from Amazon.com in a service. It offers called simple storage service. So if you want to store large data, for example, you want to store 2 terabyte data you want to store, you can simply rent it out. In order to buy any storage, you can rent it out. Once the product is completed, you can again give that back to the cloud provider. So how much time period you have used that storage, that much time period you have to pay. That's it. You can rent computation service for from Amazon.com in EC2 in its Elastic Cloud Computing service. There is a service called EC2, and this EC2 is nothing but a virtual machine. What I will be discussing this in detail. So suppose I want 50 machines, then you will get 50 machines. So and you can rent them. You can rent the computation service as well. Computation service means the servers, virtual machines. So why cloud computing is required? Pay per use. So assume I want to use for only 1 week. Okay, no problem. You can use for 1 week, and you can pay for that period. Only 1 week period you can pay. If suppose the 1 week you have used and the bill generated is only 25 rupees, you can pay only 25 rupees. That's all. Simple. You in order to pay, you know, to buy any physical machine. Instant scalability. Suppose assume a product is going on. Suddenly the team requires 10 more machines, and the time is around 2 a.m. for example. In that midnight, you want to get the machines, right? So in that case, the cloud computing, using cloud computing, you can create the 10 machines in 2 minutes. In 2 minutes, you can create 10. You can get 10 machines. Not only 10 machines. If you want 100 machines, also within 2-3 minutes, you will get the machines created on the cloud, and you can start using them. So that is called scalability. And tomorrow you created 100 machines, and now after 100 you want another 50, then 150 you have total. And later on, you once work is done, then you want to reduce to one from 150 to you want only 40 now. That means you can 110 machines you want to revoke. That means you 110 machines you don't want to use, then you can give it back to the cloud provider. And you want to keep only 40 machines, you can keep them. Only 40 machines can be run for your project for a long time. So you have to pay for only that for those 40 machines. Like that, dynamically you can scale up and scale down. So it's very easy actually. So security. So as you know, right, in the companies normally whenever they buy latest machines, what they do, they will deploy the operating system, and then they have to install the antivirus software. So all these things they have to do. So for that, they have to buy the licensed operating systems, they have to buy the licensed antivirus softwares. All this they have to do manually. But in the cloud, it is not like that. You can buy you can, by the time of renting the instance, at the time only you can choose what type of instance you want. For example, let me log into my AWS cloud. So here I'm signing as a root user, and here I'm signing. And now let's see how we can choose a operating system. You have to give your password. These things you will be see when you create the account, and then we have to enter a MFA code. MFA code is a code which a app should be installed on your mobile. From there we have to install Google Authenticator. The Google Authenticator will generate a 6-digit number secret key that you have to enter here, which I'm entering now. So this way you can uh, one minute please. Right. Now you see here is the this is called dashboard. Now I will not explain much about it now, but just I want to show you how we create a instance. For example, here I want to create a virtual machine. Now in that virtual machine, what OS you want? Do you want Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat, SUSE Linux? So many are there. Actually, this will I will discuss later on. But suppose I want to create a machine Amazon Linux, and I want how many machines you want, number of instances, how many you want. So for example, I want two machines. For example, I want two machines. Okay, how much RAM you want? How much CPU you want? I want one CPU or 1 GB RAM, or you can choose any size as per your project. Suppose I want 4 core CPU, 16 GB RAM, or you can choose two CPUs, 1 GB RAM. So many are there. Many combinations are available. You even have 96 core CPU, 192 192 GB RAM in the market. Mostly, whenever you go to purchase, you see maximum maybe 32 GB or 64 GB. But you see, even we have 192 GB RAM also available if you want, and 96 core CPU. Normally, you see in the market only up to 12 core CPU, but you see here you have 96 core CPU. So very high end devices are available on the cloud. So already these are all pulled together. Already these cloud providers already they have ready, and just choose whatever you want. Okay. So for example, I chosen one CPU, one core CPU, and 1 GB RAM I want, for example. And then this is a key pair. What is this? These details. This key pair is nothing but how the server is created by the cloud provider. How can we connect now? So that for that we require a key pair. Anyway, these details I will explain you later. But see, two machines I want. Now two machines are created. You see, create successfully initiated launch of instances. Two instances are ready now. That means on the cloud I have two machines now. In these two machines, I have already installed Amazon Linux. Both are machines are running now. Both machines are running now. Okay, both are running, and I can use them. I can connect to those machines. And remember, in this Amazon Linux is running also security related antivirus also installed. So you don't need to worry those things. We don't need to worry those things. Everything will be taken care by the cloud provider. Anyway, I want to stop them. So select both of them and go to instance state, and you can terminate them. You can delete them, right, with a click of a button. So you saw how fast we created, how fast we deleted. So this way very quickly we can create servers. And now reliability. So reliability means these servers, see, one remember, suppose you typed amazon.in, then you should, what do you expect? You should expect that Amazon website will open. But if it does not open, for example, it is taking 1 minute time, you will be frustrated, right? So something, if something goes wrong, you will frustrated, and you will go to another website, another e-commerce website. So that means Amazon will lose the business, right? So for that reason, suppose you want to buy a laptop on Amazon, but it is not running due to some reason, then you will go to Flipkart or some another e-commerce website. There you buy. That means the Amazon lost some business. So that is the reason the servers. So why the application not responded? Maybe because the application where it is deployed, that server is not running. Maybe. Okay. That means the application. See, remember, always any website you want to access, that application should be running somewhere in the world, in some machine. That if that machine is not running, then the application will not available for us to use. That's the reason cloud computing providers say that they will provide reliably they will run the server. That means the server never get shut down. That means server always will be running 24 by 7, 365 days it will be running. If anything goes wrong with the server, then the cloud provider will take care. So immediately he will create a new server with a fraction of seconds, and he will make it available of our application to the customers. So that is the reason slowly many companies are moving to cloud. And then APIs means application programming interface. So this is actually used by developers. Suppose developers can using Java or C# or some other Python. they can connect it to the cloud. So programmatically, so whatever just now I shown you how to create instances, but for that what I did, I used the AWS dashboard. But programmatically also they want to connect, developers want to connect and they want to create some services. In that case, APS is a collection of, it's a library. It contains the already it contains interfaces actually. So using that, developers can use those interfaces and they can connect to any other service on the cloud. That I will explain later on when we learning Lambda. Then what are the essential characteristics of a cloud? So what are the characteristics of a cloud? So, on demand self service. On demand self service means no human interaction is needed for resource provisioning. You just now saw I created two instances. So, there is no request actually. Just I selected two instances, I clicked a button. That's it. I got two instances. That means between me and the cloud provider, there is a software running actually. So, that software is handling all my requests. That means there is no human intervention. So, there is no delay. Because of that reason, no, there is no delay. So, resources can be provisioned with the click of a button. This provisioning is available 24 by 7. So that means anytime you can create any resource on the cloud. And for that you require internet, broad internet network access. Resources can be accessed from anywhere using the network. Need high broadband to access the resources. No physical access is required at any time. So you want 10 machines, 20 machines, you just as I created just not two machines. Similar way, you have to request for any resource by connecting to their website or dashboard. And next comes resource pooling. So as of whatever I explained, so physical resources are shared between customers. So these physical are shared between the customers. That means, as I told, Amazon cloud provider will have their own data centers on various regions. For example, you see in this, I just shown you, I created two instances. But where I created them in the Mumbai region. You see here on the right side, it is showing Asia Pacific Mumbai region. In Mumbai region, I created them. Like that, you can create your machines anywhere in North Virginia, Ohio, North California, Oregon, Osaka, Seoul, Singapore, wherever you want, you can create. Tokyo, wherever you want to create, you can create them. Create your instances wherever you want on the world. Okay, but I've chosen Mumbai. But in real time, your client may ask us to create the instances in Tokyo region. In that case, you can create your instances in the Tokyo. But these two machines which I just now created, I created them in Mumbai region. Every region will have a code. Every region will have a code. Those things we'll discuss again. So why I'm telling these things? Because physical resources are shared between customers. That means in every region. So any Mumbai region. So I'm using a term called region here. Remember, the every Mumbai region, in Mumbai region, Osaka region, they will have, the cloud provider will have their own buildings. The buildings are nothing but data centers. In the data centers, they will have the servers and other infrastructures. Those servers you can access, you can create them on the cloud by using shared basis. So that means I told you, I will explain about virtual machines. At the time you'll understand how these physical machines can be shared between the customers. For that you should understand what is a virtual machine. That I will explain in coming session. The cloud's control center decides which physical resource to be allocated for a customer's virtual services. So whenever you request, now I requested two machines, I got the two machines. So it is automatically allocated two machines for me from Mumbai region. So it automatically decides from where it has to create the store servers for me. Some advanced cloud services allow for dedicated physical resources which are expensive. So when you want a complete physical machine for you, you can get physical machine also. Or if you want only virtual machine is cheap when compared with physical machine. If you want virtual machine, you by default you get virtual machine. But you want only physical machine only, that also can be provided, but that is costly. That is costly and that is rarely used. Now, rapid elasticity. I already told you, no. Suppose I want 50 machines now, today. Tomorrow I want 20 machines more. Then you can scale up like that. So that is called elasticity. So resources can be scaled up and down as needed automatically. No need to purchase resources for a one-time peak scenario. For example, assume you have your own application, you have your own web application, and it is the people are now started accessing your website very regularly. And assume you deployed your machines in 10 servers, and suddenly many people found your website very interesting, and the customers grown slowly. Before it was daily 100 people, but slowly it increased to 300 people. So previously when there are 100 people, 10 machines are sufficient for you. But now the strength they move to 300 people now. Then automatically the demand is there, so that will be grown to automatically you can set up like no from 100 machines to 300 sorry 10 machines to you can increase to 20 machines now. These 20 machines can serve 300 people. And now assume you have given some offer. Suppose you are selling some books on your website. You have given some offers, for example. So the 50% discount you are giving for only 5 days, for example. Now in the 5 days, now again immediately there will jump in the customers. The customers now before they're 300, now they've grown to 500 now. So there's a 5 days. In these 5 days, 200 people again they join to, and they join and connecting to your server, and they're interested to buy your book, for example. So for this five days period, you want more machines. You want 5 more machines, for example. So automatically if you are using auto scaling service, which I told you, auto scaling service, if you are using auto scaling service, your auto scaling service automatically detect this high demand, and it will create 5 more instances to serve those extra 200 people. Like that your auto scaling will serve for this 5 days period, and once the 5 days sale is completed, then the demand now came back to 300 now. That means the instances which extra created 5 instances will automatically deleted by your auto scaling service. This way you can save costs also. That means you no need to maintain physically, you no need to monitor physically. So you know to run unnecessarily extra machines, you know to run as per the demand. Your machines will be created, and there is no demand, the machines will be deleted. So this way the companies can save costs. And then comes measured service. How the services are, how you can do the payment, how they are measured actually. So payment is done only for resources actually used. So how much you used, how much resources you have used, basing on that you have to pay. So for example, you have to pay for the server time, how much period the server is running, how much period only you have to pay. Suppose you are using database, so how much database storage you are using, basing on that you have to pay. Similarly, measurement is usually done in server time by second. So previously we used to have per second. Now even BSNL also they having the mobile charges per second. Like that here also we have to pay per second. So please unmute if anybody unmuted. And no need to invest money in non-used resources. So suppose non-used resources, for example, you have created an instance now. Instance is running, and you stop the instance. You can stop the instance also. For example, here in the screen, I've shown you. I terminated them. If you see here, you can stop also. And the second option is no. First option is stop instance. When you click on stop instance, then these machines will be stopped. When they are stopped, no, at the time CPU, RAM is not functioning. Those services are not used because they are stopped, no. But your hard disk is not stopped. Your hard disk having the data, it is still live. In that case, your cloud provider will charge only for the hard disk, not for the RAM CPU, because your system is not running. That way they will be very carefully, they will charge you. That is most important, we should understand. And now comes the next topic, that is types of clouds. We have three types of clouds: public cloud, private cloud, and hybrid cloud. So what is this? The public cloud. The cloud is a setup in public network. The cloud is a setup in public network. Public cloud, by seeing this, you should understand it is nothing but your AWS cloud, your Azure cloud, or your GCP cloud, your Alibaba cloud, IBM cloud, Oracle cloud. These are all public clouds. So this public cloud can be, anybody can access it. Managed by large companies, accessible through the internet, available to all clients and users. Clients have no access to the underlying infrastructure. Okay, so we can access them. You see, I created 2 instances now, just now, but I don't know how they created. I don't have any access to them physically, but remotely I can access them. I can install any software in that machine. I can do anything whatever I want, but I don't have any physical access. That is the that is in public cloud, we cannot access them. And private cloud. So private cloud is nothing but the company's own data centers. A cloud setup in an organization's premises, managed by organization's IT team. Like for example, take any big company like TCS or Infosys, anything. For example, these companies, they have their own data centers, right? So those data centers are, in that data centers will have physical machines. Those are accessible only by those companies' employees, not by you and me. We cannot access those machines, right? We are not the employee of those companies, right? So we can access, if you are using AWS, then we can create instances, we can access them because it's a public cloud. but this is a private cloud. This private cloud is managed by the companies, individual companies, accessible only in the organization's network, available to users in the organizations, uses private cloud infrastructure. So no access by other public, no access for the public. Hybrid cloud. Now it is combines both public and private. Why we require both public and private? We try to understand. A cloud setup in a organization's one will be a cloud setup will be in the organization's premises and also connected to the public. Both workloads can be separated between the two clouds. Workloads means what? See, workload means application, a project. When you suppose Amazon.com, Amazon.in is there. This is a application. That is a workload. That is a workload. It contains what? It contains normally it contains on higher level. I will say whatever you see, whenever you see Amazon.in, you see the front end. You see the front end. That is the one workload. That is a front end application. That is a front end application. Now, whatever you are seeing there, whatever products you are seeing over there, the prices, those details, your front end getting from a database. It is getting from a database. So database is another. It's database is software. That software, job of the software is storing the data, and it will give you the data whenever you ask them to get that data back. Okay, so the database is the one is software which is very efficient in searching for the data and getting and fetching the data and giving it to you back. Giving it to you means it will give that information to the front end application. That means your front end application always in contact with your database. So what are you seeing on the on your browser of Amazon website? It is nothing but the data is coming from the database. Now you want to add a product, you click on add cart, you say add cart, then it is added. Now actually that information also automatically stored in the database. So all these things are happening. So here try to understand, the front end is for public, database is not for the public. The front end, the database should be only used by the front end application. That means the database should not be accessible to public. If some hackers, if they have access to the database, then no, they can they can corrupt the data, or they can store the data which is in the database. That is the reason the database will not be available to the public. Only the front end application can communicate with the database using private IP internally. And anyway, that we discuss later on. But this database will be running in the on premises. That is nothing but on your private cloud, and your front end application will be deployed on the public cloud. Like that, both will be separated. The workload should be separated between the two clouds. That means sensitive data in the organization premises and public data in the public cloud. This way, they can separate it. And then we have the final topic that is for today. It is service models. We have three service models. One is in IaaS called infrastructure as a service. Another is platform as a service. The last one is software as a service. These three you should understand. That will be helpful for you. Normally, when you go to any job portal, there if you search for AWS administrator jobs, you see you'll get all the job posts over there. Actually, those job posts are related to IaaS, infrastructure as a service. And PaaS and SaaS, we will not see much jobs on this, but we should understand the difference between all these three. Okay, right. So now we are actually in this course, we are going to learn infrastructure as a service. This is the one. This service provided by whom? The cloud providers like AWS, Azure, Microsoft, or GCP, Cloud, Google. Okay, these people are providing this service. Now, what is IaaS? The cloud provides the underlying infrastructure. It provides all the infrastructure like computing, that means EC2 instances or virtual machines, I mean to say, networking, storage, everything you will get. All the infrastructure, whatever you buy physically, all the physical items, you will get on rent using this infrastructure service. The client handles and is responsible for all the rest. That means no, as if you are going to a computer shop and you buying a physical machine. You buy the physical machine, right? When you buy the physical machine, what you do? You'll give him the details. I want this much RAM, I want this much CPU, I want this much hard disk. Okay, many things you say, right? And basing on that, they will assemble your system. A CPU will be given to you. But in that CPU, is the shop person will ask you, do you want to install any software OS in that? Then if you are not interested, you will say, no, I don't want to install any OS, but just give me the physical machine. Just assemble with this configuration, give me a physical machine. That is what you're getting using under IaaS. In the IaaS, you get the physical machine. And once the machine, at the time itself, you can choose what OS to be installed in that physical machine. Which one Ubuntu require or Windows require. Those things you will select, and that's it. a brand new machine will be given to you. That is IaaS. Okay, most common examples are virtual machines. The cloud provides the host machine, networking, and disks. The client creates the virtual machine, and once you get the physical machine, what do? You will install whatever software you want, right? Whatever software you want, you will install on it. So you will install software on it. Normally, in this, if you work in a company, you will deploy the projects. You deploy the projects developed by the developers. You deploy them into the missions. So the development team will say that we want 50 missions. In these 50 missions, I want 10 missions should be deployed in dev environment, 10 missions in SIT environment. Those things we'll discuss later on. But this way, they will ask us, they will raise a ticket. Basing on that, we will create their missions, and then they will ask us to deploy their code. And before deploying the code, remember that whenever they write a code, that code you cannot deploy directly into a mission. It will not work. It will not work. So that application is dependent on other softwares as well. For example, you tell me, when you want to construct a building, do you start constructing the building right away? No. Before that, you dig and you lay out the pillars, and then on top of it, you start building the house. Okay, we will be staying inside the house. That doesn't mean that pillars are not required. Pillars are required, right? So you'll then only on top of it you build the house. Similarly, the developers, when they develop the code, they develop the project. So for the suppose they developed the Java application or .NET application, the application you cannot directly install in a machine. If you install in a machine, then the application will not run. It will show you an error saying that I want this particular software to be available. Only if it is available, only I can run. That way, it will show you a alert. That means every application will have its own dependable softwares. We call them as runtime environments. We call them as runtime Java runtime environment, .NET runtime environment. These are other topics related to developers that we'll discuss later on. But in this is a demo class. I am not getting into depth, but try to understand there are some dependent softwares also there. Those should be installed first, and on top of it, you have to install the Java application or .NET application. But as a administrators, we don't know what softwares are depending. That list the developers will provide us. They will say that we want this software to be installed first, and after that only install this application. Like that, they will prepare a documentation and they give it to us. So why I'm telling all these things now, that will help you to understand the second slide, the coming slide. So here the client creates a virtual machine, installs the software on it, patches it, maintains it, etc. Now PaaS. What is PaaS? Platform as a service. The cloud provides this PaaS kind of service. What they do is they provide platform for running applications. That means they provide compute, networking, storage. These things already we got from IaaS. But on top of it, they're providing runtime environment also. What is runtime environment? I just now told. So now I told you the developers will give you the details, like before deploying the application, they have to deploy, we have to install some software. That list they provide. That software is dependent software is already available in the PaaS service. In the PaaS service, those software is already available. And this PaaS environment will take care of scaling also. That means previously, if you want to scale the machines, you have to use auto scaling. Everything you have to do it manually yourself as a DevOps engineer. Sorry, as a cloud engineer, you have to do everything yourself. But in the past, you don't need to do anything. Everything they will take care. They do security updates, patching, everything they only take care. Then what we have to do then? The client just needs to bring the code to run. You have to just deploy the code developed by the developers. You have to just deploy it. That's it. Remaining everything managing the runtime, scaling up, everything the the PaaS service layer will take care. Everything they will take care. We are nothing. We are. That means say administrators nothing to do there. Only upload the code. That's it. The job done. So most common examples are web applications. The cloud provides the runtime for running the web apps. The client uploads the code and it just runs. The client has no access to the underlying virtual machines. Before at least in the IaaS, at least we can connect to the virtual machines using the key pair. I told you key pair. No, we can connect to this machine. We can install whatever software we want. We can do it. We have that kind of independent we have there. But in the past, you cannot connect also. So you will not get any access remotely also. So everything they will take care. You just have to upload the code. That's it. Remaining they will take care. The client upload. The client no access to the underlying virtual machine. That is the main difference. Understand? There's a main difference. But when you come to SaaS now, SaaS software as a service, no hardware or software to manage. That means previously at least you can ask for it will provide compute, network, storage, those stuff. But in past, and you're in the past we are uploading code, but in software service, no code also required, no hardware, no software required. Then why what is the purpose of having this service? This service delivered through a browser. That means you may be used some services, no, like no Microsoft Office, for example. Microsoft Office, this Office, you can buy it. So license, normally companies buy it. Suppose from the browser you can access Outlook. You can access Outlook. Outlook is one of the software of Microsoft's. So you can log into Outlook and you can check your mails. So that is a service. That is a software. That is Outlook is software. And that software, if you want, you have to use, then you have to pay some you have to subscribe to that software. You have to pay monthly or quarterly or half yearly or yearly. You have to pay for that. So here, like example, I said Outlook. Similarly, some companies, like Salesforce companies. Salesforce is a company, so they also they sell their software as a license based. They sell the software to other companies. So other companies, if the other companies, IT companies, if they want to use a software called Salesforce, for example, they can uh, buy it, not permanently, only for 1 year or 2 years, like that they can buy it. That's a they have to pay for the license for that. Okay. So that no, they can use that Salesforce software in their company for some period. So that means they're buying their software. So this kind of buying the software on license base, and these all things can be accessed from the browser only. You cannot install on your machine. You can access them on the browser only. So service delivered through a browser, a software completely running in the cloud. The user does not need to install anything on premises or on his or machine. The provider of the software takes care of updates, patches, security, etc. Example is Salesforce.com, Office 365. These are the examples. If you see this picture, you will understand. See, the first one is on premises. On premises means it is on a company. For example, if you take TCS, they are having their own data center. In the data center, there will be administrators. The administrators maintain from the beginning, from networking, storage, servers, virtualization, OS, middleware, runtime, data, application deployment, everything from scratch they will take care. Who? Administrators in the data center, in the physical data center. This is happening on the on-premises means physical data center. Now comes to infrastructure service. Now this is the IaaS. This is here you see networking, storage, servers, everything is already taken by your cloud provider. He already prepared it ready for you. Now you can only request, like, no, which OS you want. Everything is already ready. You know to create any networking, nothing, everything, storage, everything is available now. You just ask what you want, which OS to be installed on the virtual machine, what other softwares you want to install, that you can take. That's your responsibility. These are all things you are responsible. Choosing the OS, installing the software, everything you can take care. Your image. What is image? It's nothing. It's software actually that I will discuss later on. And then platform as a service. As I told you, you just deploy your code. That's it. You have no chance to select which OS you want to install. No chance at all. You just deploy your code. That's it. Everything they will take. In software service, everything, even application also, their own application. If you want to use their application, then you have to pay monthly or yearly or half yearly. You have to pay, and you can use their application. If their application makes important, it is important for you, then you can rent. You can rent base. You can rent them, and you can pay monthly or yearly basis, like that. And finally, advantages: lower cost of ownership. If you use cloud, if you are using cloud computing, what are the advantages you get? Lower cost of ownership. That means you no need to create a building. In that, you no need to install any servers, you need to buy any physical servers. And in data center, the server should be running 24 by 7, 365 days. So they will slowly get heated, right? They get heated, and the servers may crash. That is the reason the companies will install air condition inside the building. So the air condition, multiple air conditioners will be running all the time. So again, there will be expenses for the electricity. And again, you have to keep a security guards, various things, various expenses you have. But if you are using cloud, you no need to worry about these things. Everything they will take care. That means it doesn't mean that if you are using cloud computing, there will be no data centers. There will be data centers, still there will be there, but maintaining by one of the cloud provider. For example, AWS, they having their own buildings, their own servers, their own security guard, their own air conditions, everything they maintaining it. And how they paying for that? By the bills which we pay. So whatever you are using, we are using on the rental basis. Whatever we paying, from that they paying the they're paying their bills. So this way, you no need to have your own ownership. Reduce infrastructure management responsibility, because there is no infrastructure. Some companies like Infosys or TCS, they already have their own data centers, but on top of it, they also use cloud also. They use cloud also, both they will use. This way, they are reducing cost on the infrastructure management responsibility. Allow for unexpected resource loads. Unexpected resources means, I told you, no, today I have 50, suddenly I want 20 more. But in real time, if you want 20 more, if already 20 servers are available on your data center, that's fine. If it's not available, then you have to order. You have to give a order online. That is like every company will have their own vendors, like HP company, Dell company. These are different companies are there. So these companies will give a order to them that we want 20 machines, and they will deliver it within few days. But for that time, you have to wait. But here in the cloud, no problem. 20 machines if you want, within minutes you get 20 machines on the fly. So faster application rollout, because you have machines ready, then you can install our application very fast, and you can check how it is behaving, how our application is working. You can check that. And multi-tenanted. I told you the same physical machine can be used by multiple customers. How it is possible? Using virtualization. So what is that? We'll discuss later on. Virtualization lowers costs by increasing utilization. So because of virtualization, the cost will be decreased further. These things again, it's a different topic. We'll discuss later on.